Question number 20 is probably going to be in a couple parts. It's asking us for the area of a triangle bounded by the y-axis, the function f of x equals 12 minus 4x, and a line that's perpendicular to that goes through the origin. So let's go ahead and set this up first. We've got our line 12 minus 4x. The y-intercept, if we set x equal to 0, is going to be 12. So let's set our scale at 12. Let's do maybe 3, 6, 9, 12. It's going to go through there. And then our x-intercept, when we set f of x equal to 0, is going to be 3. So I'm going to go ahead and make this a little bit bigger. So let's do 3 here. And our line is going to go, I'm always bad at this part. Okay, there we go. This is our line 12 minus 4x. The other side of the triangle is bounded by the y-axis. So it's going to be this one. And the next one is a line that's perpendicular to this. So this slope is -4. So that means our new line is going to have a slope of 1/4. And it says that it goes through the origin. So when we set these equal to 0, we're going to end up with b equals 0. So our line is just y equals 1/4 x. So now what we want to know is, where does this, we know it goes through the origin, but then where does this intersect with this line? Because that will help us to find the distance. So what we want to do is we want to set them equal to each other, and that's going to give us one of our values. So we've got, this is already set equal to y, so let's plug this in. 1/4 x equals 12 minus 4x. So we've got sorry about that. 17x equals 48, or x equals 48/17. So wherever this point is, we know that x value is going to be 48/17. And then we can plug x in again to solve for y. So I usually pick the easiest equation. That looks like the easiest to me is this one. So we're going to plug in 48/17. And that's going to give us 12/17. Now we can find out what the distance is of those. But what we can do is we can do a quick approximation. So if you recall, the area of a triangle is half the base times the height. The base is approximately 3. And the height is approximately 12. So that's going to give us an area of approximately 18. So we'll keep going and we'll find out that exactly. But we needed to do a couple of these steps first to find out what our lines were and what that intersecting point was.